Hi again! Here's how you compute for those thermal quantities, but you need to know a few equations first. The first one is enthalpy. It measures the amount of heat absorbed or released by a system. If the value is positive, then it is endothermic or absorbing heat. Meanwhile, if it's negative, it's exothermic or releasing heat. The second is entropy. It measures the disorder of a system. The more it increases in a system, the value is positive. If disorder decreases, then the value is negative. Lastly is Gibbs free energy. It determines if a reaction is spontaneous or not. If the value is positive, then it means the reaction is non-spontaneous, while negative value means it is spontaneous. Now it's time to compute. This process has 2.3 moles of glucose and 14 moles of O2 in the reactant side, and 14 moles of CO2 and 14 moles of H2O in the product side. Now for each process, you have to first find their standard molar enthalpy, entropy, or Gibbs free values of each compound. Afterwards, you multiply the number of moles of that compound in the reaction with that value. Next is that you follow the equations, which is always said to be products minus reactants. That's very important. Products minus reactants. Now this process has 2.5 moles of glucose and 15 moles of O2 in the reactant side, while there's 15 moles of CO2 and 15 moles of H2O in the product side. We do the same thing. Find the standard molar enthalpy, entropy, and Gibbs free values of each compound, multiply it to the number of moles of that compound, and then follow the equation, products minus reactants. As for finding the total enthalpy of triglyceride, we have to find the Lewis structure of the compound first, which is this. Next is to find the values of the bond energies found in this structure. Don't worry, it's not as intimidating as it looks. Now once you have them, you can plug it into the equation of the reaction. Just like before, we multiply the number of moles to the bond energy value of the compound. Lastly, to get the enthalpy of triglyceride alone, you follow this equation, which is breaking bonds minus forming bonds. Now we have all the components we can get for the enthalpy of the oxidation of triglyceride.